Welcome back, Algebros. Today we continue our lesson into functions, this time talking about something we call input and output maps. Recall that we talked about how inputs are the things we put into the grand machine, and the outputs are the things that come out. We denoted inputs and outputs, the set of them at least, by domain and range. Our goal this time is going to be when we're given a relation in the form of a bunch of points. How can we determine if that relation is a function? See here, we got a bunch of points floating out in space, 2, 4, 7, 1, negative 1, 1, and 12, 0. How am I going to determine if these things make up a function? Well, let's find out. We have to create something that is called an input-output map. For simplicity, let's assume that the points that we're given in this case, and in any case, are the only points that exist in this function, in this relation, sorry. We've seen that as the case before in a couple of our examples, and we're going to assume that's the case for these kinds of questions. We're going to start off by writing all of the x's, or in other words, the inputs, on one side, and all of the y's, in other words, the outputs, on the other side. Most of the time we have the inputs on the left and outputs on the right. It's only natural for us, as reading from left to right, but that makes sense. Then we're going to draw an arrow from each input to its respective output. Not to whatever, but to the one that it came from based on the point. Finally, we're going to see if any input happens to be giving more than one output. We saw this before in the K controller example as being a broken controller, pressing the jump button, and sometimes it's jumping, sometimes it's punching, and sometimes it's throwing you directly into the ceiling. Depending on that result, if the answer is yes, that one of the inputs has multiple outputs, it's not a function. If no, it is a function. It's a bit backwards, but it's mostly a test for a negative in this case, because if we disprove one situation, we've disproved it being a function as a whole. Let's see how that looks for this example up here with these 4 points. I've already done the honors for you guys of writing out the input and output map as it should be. Sometimes we like to put them in a little bit of a box like this, where one bubble is going to signify the inputs, and another one is going to be the outputs. But these are the same points as they were. That's step 1 covered. Step 2 is now going to be these arrows. I'll denote that with green over here. 2's output was 4, 7's output was 1, negative 1's output was negative 1, and 12's output was 0. Just make sure we're not mixing these up along the way. But step 2, just draw an arrow from the input to the output. Because we knew these points were 2, 4, so that's why 2 is going to 4. 7, 1, that's why 7 is going to 1. Negative 1, negative 1. We can have identical inputs and outputs. That is possible. And 12, 0, so it all makes sense. Now let's look at each input in order to go for step 3. Is any input giving me 2 possible outputs? Well, 2's only got 1 output, that's 4. 7's only got 1 output, and that's 1. Negative 1 only has 1 output, and that's negative 1. 12 only has 1 output, and that's 0. So this question over here, whether any input at all has 2 or more arrows coming from it, that answer is no. So in this case, the answer here, is this relation a function? Yes. It's a function. Hooray, it didn't make us throw the controller. So let's recap. We list out the inputs in one column, the outputs in the other, and then we're drawing these green arrows back and forth in order to tell us which input is going to which output. It's kind of like designing the game controller from the previous example. After that, we see if anything's broken. Does any input sometimes give one output and sometimes another? In other words, is there an arrow, are there more than one arrow coming out from any input? In this case, that didn't happen, so it's a function. Let's explore another example. This time, let's see this one right here, where we're going to use input and output maps to determine if each relation is a function. The way you show your work here is nothing more than the same input-output map you see here. So I'm going to go right out the gate and set up the input and output columns. So let's start off over here by writing the input-output mapping. I'm going to list out all of the x's here as the inputs. First x is 1, second x is 5, and the third one right here is also 5. Keep a note, don't repeat numbers. So, if we have 5 twice, we're only going to write it once. Otherwise, that will throw us off. That was the x's. Now let's talk about our y's as our outputs. I see 3, I see 7, and I see 10. And that was step 1. Let's talk about step 2 now, which is going to be to draw an arrow from each input to its output. 1 outputs 3, 5 outputs 7, and 5 also outputs 10. And that's step 2. Step 3 now. We look at each input and see if anyone has 2 or more arrows coming from it. 1 has only got 1 arrow, so it's fine. But 5 has 2 arrows. One of them that's going to 7, and the other one going to 10. That's a situation where the button B is either throwing you in the sky or plummeting you into the ground. Which do you want? Probably neither. But whichever it is, this doesn't function properly. So is this a function? Nope. Also, if you ever see FCT in the future, that's my abbreviation for function. Might want to write that down. Our next example will be this one. Once again, the first thing I should be thinking about is our input-output mapping, since I'm given a list of points. Let's write down each individual input. I see -1. The next x-coordinate is 12. The next one is 10. And the next one is 3. Now for the outputs, I've got -2. I've got 1. I've got 2 again. And I've got 3. Now let's draw some arrows back and forth. -1, 2 was a point, so -1 is going to go to 2. 12, 1 was a point, so we're going to go to 1. 10, 2 is a point, and 3, 3 is a point. Keep in mind, the way that we designate inputs and outputs is given by each point. If we have a point, -1, 2, that means that -1 goes in, and then comes out as 2. Just keep that in mind. Now looking at each one, no input here has 2 arrows coming from it. -1 is by itself, 12 is by itself, 10 is by itself, 3 is by itself, each give only 1. So the answer here, is it a function? That's a yes. A way you can tell very visually is if you see any repeats. So if you see a repeat of x's, it's not a function. You still have to show your work, but that's a quick way you can check your work. This last one over here. I've talked before about a repeat of x's means it's not a function. But how about a repeat of y's? Well, let's find out. The inputs here, I've got 7, 12, and -5. But the outputs here have a very special case. I only have one kind of output, and that's 1. So is this a function? Let's draw arrows. All of them output 1 in this case. So each one of them has an arrow going to 1. We see that 1 has 3 arrows going into it. But does that disqualify it from being a function? No. Notice here in the instructions, when we talked about the question for step 3, does any input have 2 or more arrows coming from it? It says nothing about outputs. So the output could be a duplicate for some of them. But here, each of these inputs only has one exact output, even if it's a common one. Each one only has 1 arrow coming from it, so is this a function? Yes, indeed. Don't let this mix you up, because repeated y's are fine. These last 3 will be U-tries for you to give a shot. They're not too long, and with the trick about knowing how to handle duplicate x's or y's, you might be able to get them immediately. Can you not get frustrated and not throw your controller over a busted one that makes you fly up in the air or crash into the ground? I hope not. I'll see you in class.